Today we're going to talk about balancing chemical equations. The first thing we want to remember is that the law of conservation of matter governs balancing equation. And the law of conservation of matter tells us that all elements must be equal on both sides of the arrow. So that means that I have to have an equal number of each individual element on both sides so that I do not destroy any matter. To balance chemical equations, we're going to use coefficients. Coefficients are large numbers that we put inside or that we put before each of the elements or compounds, and that will equal those out. So when we start our sample problems, what we'll start by doing is making ourselves a little tally sheet and list each of the elements in the order that we see them on the reactant side. And then we'll just copy the same thing onto the product side. So in this first sample, we have sodium and chlorine and lithium. And then I'll write those down in the same order on the product side. NaCl and Li, and then I'm going to go back and I'm going to put in the number of each element. If there's no subscript, it's a 1, so there's 1 Na, 1 Cl, and 1 Li. On both sides, they're all equal, so this first example problem is already balanced the way it's written. In the second problem, we have iron and oxygen, so we're going to write down Fe and O. And then we're going to repeat that on the product side. And then we're going to write down the numbers of each that we have. And we have 1 Fe and 2 O's on the reactant side, and 2 Fe's and 3 O's on the product side. So we'll start off by balancing our O's since they're not an easy one to look at. So we're going to find the least common multiple. And what we want to do is get that equal to 6. So on the reactant side, 2 times 3 is 6, and on the product side, 3 times 2 is 6. And we'll put in the coefficients of 3, what we're multiplying by. For the reactant's oxygen, and on the product's oxygen, we'll put in a 2. That gives us 4 Fe's on the product side, so we need to multiply the reactants by 4 to get those straight. In the next sample, you'll see that we have potassium chromate and lead nitrate. So since the chromate and the nitrate do not separate, we're going to leave them together, and it'll just make the math work out easier for us. So we write down KCrO4, Pb, and NO3 on both sides. And then we go about writing down the number of each that we have. So we have 2 potassiums and 1 chromate and 1 lead and 2 nitrates on the reactants. And in the products, we have 1 potassium, 1 chromate, 1 lead, and 1 nitrate. So you can see the potassium and the nitrates are not equal. So we'll start with the potassium, multiply it by 2 on the product side, put in the coefficient of 2, and that'll change our nitrate to being 2 also. So now all of those are equal. And in the final example, we have a combustion reaction. And so we write down our elements, C, H, and O. And we have 3 C's, 8 H's, and 2 O's on the reactant side. And on the product side, we have 1 carbon and 2 hydrogens and a total of 3 oxygens, because the oxygen from CO2, there's 2 of them and 1 in water. So if we multiply the carbon by 3 on the product side, that will give us 3 carbons. It also changes the amount of oxygen, and you see that 3 times 2 is 6, plus the 1 is 7. And then we work on the hydrogen, and the hydrogen, we have 2 of them, so we need to multiply that by 4 to get 8. And then that changes my amount of oxygen to 10 now, because 3 times 2 is 6, plus the 4 from the water gives us a total of 10. So on the reactant side, if we multiply the number of oxygens by 5, that will give me 10 oxygens on the reactant side, and I put in the coefficient of 5, and that'll take care of that reaction because the carbon, the hydrogen, and oxygen are now equal.